Hello everyone, my name is Piotr Pasich and today I'd like to give you a quick introduction to the message queues, message brokers, especially the RabbitMQ, which you can see in the background because this is one of my favorite ones. And why and the pros and cons I will give you in a few seconds. But first of all, let me introduce your speaker. I am working as a senior software developer at X-Team company. Which is localized mostly in the Australia, but we are working remotely all around the world, probably now from Australia. You can find me on Twitter account and on my personal blog website, and this presentation was given on the For Developers conference in April, as far as I remember, 2017, and I really appreciate the invitation for this conference. This is why I decided to record that once again in English. So, shall we start? Yes, we shall. The main part of the communication in the internet works in a direct way. So we've got our server, which mostly is Apache, Nginx, or the standalone Symfony server, or just the Node.js server, which will communicate with some services. The most popular example in the message brokers, articles, books, and other stuff is based on the sending email. So basically, if the user will register to your website, you will be able to, you want to send him an email with the I don't know, thank you email, the activation link email, token email, or something like that. Basically, you got your Nginx or Apache server on the left side and SMTP server on the right side. If the user registers, you would like to send the prepared email to the service. And at this point, everything is going on. If everything is going on right, the server will respond you the 200 response, and the user will see the successful message. But if something fails, like the service cannot deliver the message, the service is busy with something else, or the service is unavailable, then probably user will see the message 500 or something similar to that, and that's a huge problem because we wouldn't like to bring our problems to the end users. We would like to handle that by ourselves, and in the perfect world we would like to deliver that message until the service will start up, or until the service will just be able to deliver that in a short amount of time. So what can we put in between to do this? And this brings us to my favorite example, which I had a couple of years ago. That was a an application, affiliation application, which we've written 7 or 8 years ago. We were asked by our investors to create an affiliation application where they can put the advertisement, the text, articles, banners, videos, and so on, and share it with the advertisers, which will be able to put the advertisements on the websites and get the fee from the leads. The lead is, of course, the order. So if somebody orders the product on website A and seeing the message, the advertisement on website B, then probably the advertiser B will collect the fee from the order. And at the first point, we created, I remind you that that was 7 or 8 years ago. And I was pretty young and not experienced in the professional programming, so we decided to go with something, some kind of technology we used to know. That was Zend Framework 1.11 and the MySQL in version 5.0 or 5.1, something like that. So basically, we created a MySQL database schema with one table, which were actually the heart of everything what was inside the system. The table was called the action table or the actions table, something like that, and we put every single lead as a record. So there were records like views, like clicks, like orders, like something like that. We reached at the very first time we were on the production about 150 leads per minute. That was a huge number, which brought us to a big fail, because we had a really huge server which actually failed everything, because when the InnoDB MySQL saves the data, it immediately recalculating the indexes, which stops everything as every other action on the table, like reading or writing other records. So basically the records were not writing because the indexing were recalculating, and the queue of the re-indexing things and re-saving things and reading things in the same table were longer and longer and longer at the second after the seconds, and after just a half an hour we had a load average on the server like 200 or 300, so the server failed and we needed to restart it every hour or so. So we decided to create a new table without any kind of the indexes in the InnoDB. That was memory table which were inside, and that was surprisingly called actions temporary. Every single minute we run a cron job to move the records from the actions temporary to actions, and the InnoDB were able to recalculate the indexes every minute or 2 minutes. That took about, recalculating the indexes took about a second, and everything was fine. We were able to handle about 300 requests per minute or 3000 requests per minute. It doesn't really matter, it works until now. So after 7 or 8 years, I do know that what we did was actually called queuing messages, and that table was a really simple example of that. But the most sophisticated example of that of using message queues is based on a few years later, where we face a problem to create a system for DTP, for printing a huge banners and advertisement to the city, and every single image uploaded to our service was like 200 megabits or 300 megabits, and resizing that takes a lot of time. This is when you resize one image, it's not a huge amount of time. This is like 3 or 4 seconds. But when your investor puts some kind of sale of the promotion, then probably you will need to resize about 200 or 300 messages at once. So it takes a lot of time. And the examples go more and more advanced in the time, because a year after that we needed to create a system similar to YouTube, but for the pupils, for the students, so where they could see the the lecture or the classes on the website, and just day before going to the production, every teacher decided to upload the video. They had about 2 weeks of time for doing that, but every single teacher decided to do this last hour, so we needed to scale our application. And that's what Message Broker brings us out of the box. So we could use our servers, Nginx or Apache with the Node.js, to show the users, the teachers, how actually the upload process goes in the time. So it's 1 person, 2 person, 3 persons, 4 persons, and so on. But that was on the left side of the servers were actually the Node.js type, and the services. The services was written in PHP, which actually handled just one command to execute the MP4 convert commands to convert every kind of the video to 4 or 5 kinds of resolutions. But we are not going to use the word server and the service today. This is more complicated. Actually, the message brokers were introduced in the late 80s by the IBM, and IBM has a manner to use such a sophisticated words like publishers and consumers, and for the next decade that was used only by companies which use huge infrastructures, that was dedicated only for some kinds of IBM, Sabre, Microsoft, or some other companies which had some money for putting resources to develop new services and the message queues. And that was mostly based on the AMQP or MQTT protocols, which we will be talking in a minute. But as you can see, the publishers are our servers, and they publish the messages to the message to something in the middle, and don't know actually what's happening with the message. And the consumers gets the message and don't know actually which service published the message. This brings us a huge opportunity to scale the number of or reduce the number of consumers, or do the same thing with the publishers. But the main thing is we don't know what's going on between. And that brings us to the example with the post office. So basically, just imagine your boss is a publisher, and you as a message broker standing up in the post office is the message broker. You are part of the queue and handle the message and going to the consumer, and probably consumer will get the message and do something with that, but actually you don't care. In the real world, when you get when you bring the message to the post office, probably you care, but you don't know what's going on with the message after that. And in 2006, probably 2006, two guys decided to simplify this process and bring the technology actually to the wider to the programmers by creating a really simple to install framework called RabbitMQ. So they decided to create a technology that is really simple to start. You just need to install the RabbitMQ, and brings a lot of opportunities and a lot of configuration values to modify your expectations and the behavior of the message broker. They decided to base the RabbitMQ on the advanced message queuing protocol, which is more sophisticated and more advanced than the MQTT, and can bring you a lot of things inside. This protocol was introduced a couple of years before, and RabbitMQ authors decided to stick to the version beta, alpha, something like that, 0.9, and from now on there is a stable version of the protocol 1.1 or something like that, and you can, but they decided to actually stick to the previous version because in the newest version, the stable version, there is no such things as exchange or something like that, and they think that the exchanges and other things are really the heart of the querying and message broking and so on. So that's how the RabbitMQ works in such a good way. And advanced message queuing protocol divides the system on some parts, which is of course the message broker, which takes care about all the communication between the service between the publisher and the consumer. But to make, and this is the most simple way we can create the queue, but for the security reasons, the message broker is divided for the virtual hosts, and that works as virtual hosts in the Apache. So basically you got on the one server a couple of message brokers installed on the same instance of the application, but actually it is working as many instances of on the servers, and one message broker needs to have at least one virtual host. The virtual host doesn't share the users, the consumers, the queues, and so on, so they don't know actually anything about each other. So that brings us to a huge opportunity in the security world. We can actually use one message broker for a lot of applications, like we use the Apache on the shared hosting. On the left side we got publisher, and on the right side we got the consumer. Inside the virtual host we got Exchange, where actually every single published message is initially published, and the Exchange takes care about into which queue the message should be delivered. The little arrow between the Exchange and the queue is called binding, and in the most simple example, the Exchange queue binding is just a direct, so one Exchange brings the message to the one queue. That's the most simple example. We will talk about more sophisticated, more advanced examples in a minute, which are called the exchanges, and the exchange can deliver the message to more than one queue. And we got the channels. When we connect to the broker, we create a channel which are communicating with the broker, and the queue can deliver message to one channel, that is the basic option, and to many channels, that is more advanced option, bands. So that's all I think about the inside structure. And if we decide to put that structure into a box, then it will be called a standalone instance of the RabbitMQ. But the RabbitMQ has own resources and can deliver only some amount of messages at the time. Probably in the basic configuration it is such as 1 million or 2 million messages per minute, but it's huge amount. But probably you will be using some more advanced options which brings the performance down, so you will need to scale not only the application but also the message brokers as it is. So if we add one more message broker next to each other, it is called a cluster. They can copy the message, they can replicate the message between each other, then can be copied and deliver the message to the consumers. But we can create also a federation, and federations are something what is described in the AMQP protocol 0.9, but they resigned from that in the 1.0 protocol, like the exchanges. This is why the RabbitMQ uses a 0.9 AMQP version. So basically, the message broker cannot publish the message not only to the consumer, but the other message broker can be also the consumer. So this when you publish the message or publish the message to the other kind of the message broker, this is called a federation. So as I said at the very beginning, the RabbitMQ installation is really simple, and to be honest, you will need in the Ubuntu or other kind of a Linux server only the latest line of that, but I decided to put you a full installation guide, 3 lines, and after that you are ready to go. So just you use the apt-do, the yum or the apt-get install RabbitMQ server, and that's it. What is not pre-installed in the Rabbit server is the message administration panel, which is created as a plugin, because RabbitMQ has a huge system of extensions and plugins which can be delivered and installed out of the basic installation. So the management system is also such kind of plugin which should be installed. So to install the RabbitMQ management plugin, you need to use the RabbitMQ plugins command in the command line. Install it or enable it, like enable in the first line, you can see that, and restart the message broker because some changes has been in the configuration has been made, so you need to restart or just refresh the configuration. The management system will be available on the 15672 port and on the HTTP protocol, so you can use the website and go through your Chrome, Firefox, on whatever you use, Internet Explorer or Edge, and just open the website, and it looks like that. It brings you a full overview of what's actually is going on inside the RabbitMQ, so you can see all the connections, all the channels, exchanges, queues, and manage the user. How you can log into the website? By the default credentials. The login is guest and the password is guest, so probably you would like to change that because the port is available for external connections and you wouldn't like to connect to make somebody else allow somebody else to connect to your message broker. To do so, you need to just, I don't know, add new user by my RabbitMQ. CTL is the main command you can manage your system, and of course everything I'm presenting to here from the command line is also available from the administration management panel, but we're not clicking on the interface, we're just using the command line. So that's how we do this in the command line. You can add new users. In our example, this 4 developers user with the 4 developers 4-3-1 password, a really sophisticated password, and we like to give him new permissions which are in the message brokers or in the RabbitMQ world called tags. So we promote the 4 developer users, 4 developers user to the administration role. We could, and we should, of course, change the password for the guest to the confidential password, like confidential password or 12346. And that's all. For now, we are more or less secured. But this is, of course, the PHP presentation, so we should bring some code. And the main advance of using MQP library is that for every single language you can find some kind of library dedicated to use. So the MQP organization decided to publish the library or the plugin or the module for all kinds of technologies available on the market, which are more popular. So we can use the PHP-MQP lib. For the PHP, we can use the library dedicated for the Node.js, for the JavaScript, for the Ruby, ROR, for the Java, for the C++, for the C#, and so on and so on. We can communicate our applications between the other applications, and we don't actually care what language they handle or how they are written. We can. There was some year ago or something an example that the Node.js can actually handle really good some kind of calculations, and this is a good idea to actually send the calculations from the PHP to the, if you got of course some kind of 3 or 4 millions billions records to calculate, send them all to the Node.js from the PHP application, send them back, and that's much faster than using actually the PHP calculations. That was something related to the arrays, and that's really possible. The basic example, we can create a stream connection to our AMQP server, which is in our example the RabbitMQ, and connect with the guest user. The password should be of course changed. As I said at the beginning, we should connect also with such kind of the channel. And the third line brings us first difference between the mindset of the MySQL or Postgres or some other kind of database, relational or non-relational, because we don't create the queues or the data buckets from the administration panel of the message broker, but we create the buckets or the queues at this point from the code. So actually at this point you need to create a queue, and if it is not created already, it will create a new queue, and if it is already created, then it will be using the existing queue. So, but we can of course change that behavior, and I will show you every single attribute in this method in a second. You can create a simple MQP message, which is an object, and say hello world. You can the hello world can be changed into the JSONized object, array, file, whatever you want. So you can just put there a JSON format or the XML format, just a simple text, send it, and the code on the other side. That works as a REST API, just like that. Publish the message to the queue, hello, and that's all. That's all what we need to do. The functions, the method, the attribute of the method, queue declare, which is really important, should be every single queue should be declared in the same way on the consumer side like in the publisher side. If you will declare the queue with different options, probably the code will fail, and the message broker will return you message that something is not well with the configuration, because you got different configurations on different points. So basically you declare your queue with the queue name, which can be just a string. Passive means that the queue is created when it doesn't exist, or is not created when it does exist. If the passive is set to false and the queue doesn't exist, probably the code will fail. Durable means all data or all messages saved into the queue will be available after the server will be restarted. This makes the performance down a little bit, because of course the hard drive is much less fast than much slower than the RAM operation memory. Of course everything is safe on the hard drive and probably replicated. So this makes you more so this brings you to the opportunity that you will be able to restore the data and the messages after the server fails, or after the server just restarts. Exclusive means that this queue will be available only for one publisher, or can be consumed by only one consumer. Auto delete means that you can the messages consumed by the consumer will be auto-deleted. You can, if you say the auto-delete is false, then you need to give an information from the consumer that this specific message should be deleted after all, and the free of others. Then weight is not important for us, and arguments is just kind of a headers, which we'll be talking about in a few minutes. The consumer side. So in the case of consumer, as I said at the beginning, we need to create the basic channel at the same way as we did at the first place. The arguments are placed in the same order, but at the very end we got as an argument the callback function, which will be called when we actually get the message. And here we just echo the received message string, and that's all. We put everything in a while loop back, that the process won't be killed after connection after making a success connection to the message broker. So it will be living as long as it is possible, or as long as it is not failed. So the basic type of the communication brings us to the simple diagram. Then we have a publisher which publishes the message to the message broker, and the first message is delivered as a first to the consumer from the message broker, and this is called a direct connection. So as I said before, every single queue is not just a queue, it is a pair of the exchange and the queue. So we basically not publish a message directly to the queue, but we publish this to the direct exchange, which is connected to the one address x1 direct, which is published to the queue, one queue with this address, and which is published to the consumer. That's all. The code is pretty simple. We just create the direct exchange, for example, for the direct logs, and it is just a copy of creating a queue, and works in exactly the same way, but the name is changed. Why? Because we can change right now something to more sophisticated. We can use topic exchange. Every single queue is create with some kind of the topic of the name. So you can create a queue called, and that is what we created in the last application for the bigger company from Silicon Valley. They decided to create such kind of the plugin for the Chrome extension to share the knowledge or the news or the information between all the departments in the company. So because they had about 3,000 of the employees, so every employee were assigned to one or two or three departments. In example, I as a programmer was assigned to the team 1, to the research and development, and to the programmers as it is, and to the group company. And the message which should be brought to such kind of the groups were not handled programmatically by handling the permissions to the message, but we were publishing one message with the prepared topic to the exchange, and that exchange took care about that to which users to which groups the message should be delivered. So basically, when we were going to publish the message to the financial, we created to the financial team, we created the message with the financial topic and the exchange delivered that to the selected consumers which were using the financial queues, and that's how it works. So if we just select the exchange exchange1.financial, exchange2.ceo, exchange3.programmers. We can use just the star to send the messages to all consumers started from x1 string. Declaring this kind of exchange is really simple. We need to just choose the routing key, declare new exchange in the topic, in the topic exchange type. This is a second parameter. The first one is of course the exchange name, and just push the message with the routing key, and this will be delivered to all consumers with the same configuration. On the other hand, we had a kind of a group called company, but it is not necessary to create that kind of exchange to deliver and assign every kind of user to this group, because we got an exchange that delivers every single message to every single consumer. And in this particular example, we called it funnel exchange. This works like a topic exchange with the topic key like a hash. And to declare that, we declared a new exchange with the exchange name, with the type fanout, and rest arguments are familiar to you. So that's all. And as I said, with the queues, the exchanges should be created like in the same way on the publisher side and on the consumer side. At this point, I was asked on the conference that how to handle that kind of the situation where you need to deliver and you need to be sure that the message will be delivered to every kind of the consumer. So in example, we got an information about the update of the available update for the application. And we need to be sure that every available application will be updated or upgraded next when it's available, when the time is available. So basic solution is to create just a kind of a fan-out exchange or the topic exchange with the title of upgrade or update. And on the other side, the consumers will create the same kind of the exchange bar with the name and just get them and just get the information from that. So with the auto delete set on false, so the message will be available all the time, but will be delivered to the one exchange with one queue only once, or the one channel. And of course, we need to handle this kind of situation when we don't have any kind of the consumer which can handle our message. So basically, our publisher sends a message to the exchange, and on the other side, we got consumer which is communicating with some shipment company like DHL or FedEx or something like that, and this API is not working. So we would like to get the message within 2 or 3 days that the delivery wasn't actually ordered to us, and the package won't be able to be delivered to our customers. So we need to handle that. So we need to handle that in some kind of other ways. We can of course create an advanced system to handle all the messages and all the queries and actually report that thing, but we can use something what is called dead letter. We add a header to the message, or we declare the exchange and the dead letter exchange with the parameter that the message can live there only for 1 or 2 days, and after that this reported to the dead letter queue, what it is handled by some kind of the login system which sends the email to the administrator that the DHL's API doesn't work and we need to handle that package in some kind of other way. Probably we need to call or we need to inform the user that the delivery will be postponed. We have a couple of kinds of the dead letters which we use in a couple of types of the situations. We can create the dead letter queue exchange if the message is simply rejected by the consumer. So if it sends back the information that the message is basic reject or basic neg, and we got this information that it should not be brought back to the exchange where it was delivered from, but the message goes to the dead letter. We can give the TTL time, which is basically the same example with the DHL company, that we cannot deliver the message to any consumer, and the message cannot be consumed by anybody. So after such some amount of time, we just move the message to the dead letter and inform the administrator that something is not going on, something is wrong with the system and he needs to take care about it. And we can limit the queue to some length and just reject every single message that is reject every single message when the queue is full. So then the message cannot be delivered to the exchange or to the queue, will be moved directly to the dead letter. And declaring dead letter is really simple, works in the same time, and as I said, the message can be delivered can be published with the information or with the header that it can be handled by the dead letter if something goes wrong, or we can just create a queue which has an information about that, what should happen with the message when it's not delivered properly to the consumer or when it's rejected. So in our example, we will declare the queue with that, but we can use that, of course, with the exchange. The 1, 2, 3, 4, 5, 6, 7th parameter is the arguments, and we can put there the AMQP table object where we put the headers with the information about which dead letter exchange we use for delivering that. With undelivered messages, we put that TTL information that our message lives for only 15,000 seconds and expires after 16,000 seconds. And that after 16,000 letters, the message will be moved from our test queue to t-test1 dead queue. And that's all. Of course, I promised on this presentation that everything will be brought to the Symfony use case, and such kind of nicely done modules and plugins gives us an opportunity to do all of the stuff from the YAML configuration. I like the YAML configuration. I'm a huge fan. Obviously, I don't use XML. This too advanced for me. There's too much things going on in between the arguments and the children, and I really appreciate the annotations, but that's not the point where we can actually use the annotations. So basically, I decided to use the RabbitMQ bundle for which is working actually as kind of a bridge between the AMQP library delivered by AMQP organization and the Symfony as a framework. It delivers us an opportunity to define the configuration, the exchanges configuration. As you can see, we got everything on place. We can put there not the default arguments like it was in the previous example, but we can put there any other kind of arguments. We can create the queue, the producer, and the customer. Everything is on one place. To use that example, to use that configuration, we need to just get the service and publish the message to the queue. That's all. It will handle everything for us. On the other hand, we got the consumer, which should implement the consumer interface, and it will handle our message. In this example, this will just print the data delivered from the message broker. And that's all. I got one more example or some kind of surprise for you, because I said the communication within the message broker or the producer and the consumer works as it is in the REST API. Actually, we can override the REST API and handle that to make it more scalable, because right now when you got your REST API, in example, you handle an application which works with the Node.js frontend, which is calling the PHP REST API in the backend, you do it directly. So what happens if you would like to put a second instance of the REST API server? Actually, you need to think about it and handle the communication between the front end and back end in some way. You need to think what kind of load balancer you would like to create or something like that. Or you can use your RabbitMQ as a load balancer between your Node.js application and the backend API. So basically, on the left side you got the client, which is written in the Node.js, and it is our Node.js application. And on the right side, the server is our API, the REST API written in Symfony. The client creates a queue with correlation ID in the headers, which gives an information for the message broker that you as a Node.js application, as a publisher, expect to reply information from the server. If you add the correlation ID and reply to queue parameter, it will be published to the queue RPC queue. And this the server, the consumer, will get the information, will get the message from the RPC queue and publish a new message, which is actually your response from the REST API, to the reply queue with the correlation ID, and the client will be able to get the new message from the new queue, reply queue, and it works like the actual REST API in this example. But on the other hand, if you will need to add new instance of the API server, you can just add it. As we said at the very beginning, the client, the publisher, doesn't know anything about what's going on behind the RabbitMQ, so there can be one server, 5 servers, none of servers, and it can just receive the message from the reply queue. The way that we program that and implement is really simple. We just get and this is a Symfony example. We just get our producer as a service. We create a new object, RPC consumer. We define it, and we call the method. We just publish the message, which is called RPC message, to the rpc.message queue, and we need to consume and wait for new queue. That's all. We define the timeout, we define the callback function, what's going on when the message is delivered. We can of course define the message, define the way how the failure or error situation is handled. And that's all. That's all what can be handled. On the other side, everything is working as it was working with a simple exchange. So with this situational and extra example, we finish this presentation. If you'd like to if you really enjoyed this presentation and would like to go deeply inside the RabbitMQ, I recommend you two books about the RabbitMQ. The RabbitMQ Essentials is basically the introduction from the very beginners to the advanced users and goes through the whole documentation with the examples and with other stuff and explains you exactly how RabbitMQ works inside the all configuration possibilities and opportunities, and you will get a pretty full knowledge about that, what is inside the message brokers and how can you solve problems with that. But if you really want to get only meat and such kind of a list that you got a problem, here's a solution and the code for that, I really recommend the RabbitMQ cookbook, which brings you about 200 solutions for different problems, and you can handle that with how to install the management system, how to declare new exchanges and so on. But firstly you need to get some basic knowledge about that, which can be done after this presentation. That's everything what you need. So thank you once again. I endorse you that you can follow me on my Twitter account or just add my personal blog to the Feedly, and see you later. Goodbye.